Okay, this walkthrough is from cycle 3, and it's finding outliers mathematically. So sometimes we look at a set of data and we see like, wow, most of these numbers are pretty close together, but there's this one or two numbers in our data set that are way off from the standard number in our data set, and we realize that's an outlier. And it's really obvious to see sometimes. Other times, the numbers all kind of seem fairly close together, but you see a few numbers that are maybe a little too big or a little too small, and you can't really determine just by guessing if it's an actual outlier or not. And so sometimes we have to find outliers mathematically. So remember that outliers are the numbers that are far from the data. They've gone off the path, so they're not close enough to what the other numbers in the data set are to be considered part of the data. And outliers really affect the mean. So if you have numbers, most of your numbers between maybe 1 and 10 in your data set, and then you have the number 100, that 100, when you find the mean of the data set, is really going to affect your mean, your average. It's like if you were in class and you do really, really, really well on all of your assignments, but you bomb a test, that bad test grade now brings down your grade, your overall grade, a lot. So an outlier really affects the mean. Outliers mathematically are numbers that are more than 1.5 times the value of the inner quartile range beyond the quartiles. So we'll get what that means here in a second, because that's a lot of words. So in this box right here for outliers, I just want you to write that you take 1.5 times, so 1.5 times the inner quartile range. That's the math that you're going to do. You're going to take 1.5 times the inner quartile range. Okay, well, what's an inner quartile range? So over in the other box, it says inner quartile range, IQR, is the difference between Q3, quartile 3, and quartile 1. This is actually just the length of the box on a box and whisker plot. So what is the inside range of my data? So we'll take Q3 minus Q1, and that is our inner quartile range. So let's put this to an actual data set. Does the following data set contain an outlier? Well, first thing we have to do is we need to write this data set in order from least to greatest. So we have 0, 1, 2. Let me erase that real fast. It looks messy. Okay, let's try it again. We have 0, 1, 2, 2, 4, 4, 5, 5, 6, 8, 16, and 24. Let's make sure I have all of my numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool. So find the inner quartile range, Q3 minus Q1. Well, to know that, we have to know what Q3 and Q1 are. So to find Q1 and Q3, we have to know the median of our data. So the median of this data is the middle number. So we have 0, 24, 1, 16, 2, 8, 2, 6, 4, 5, 5. So our median is right here at 4.5. So our median is 4.5. So that means our Q1 is right here. And the difference, or the middle number between 2 and 2 is just 2. So Q1 is 2. And then that means that Q3 is between 6 and 8. So Q3 is 7. Okay, so the inner quartile range, Q3 minus Q1. So I have 7 minus 2. So my inner quartile range is 5. Now, I go back up here to this right here, and I take 1.5 times 5, and that is going to give me kind of my boundary of where my numbers are allowed to exist, and anything outside of that boundary is now going to be considered an outlier. Okay, so 1.5 times 5 is 7.5. So to find any lower outliers, any outliers on the lower side of our data, we're going to subtract this answer from quartile 1. So quartile 1 is 2 minus 7.5 equals negative 5.5. So any numbers in our data set that are below negative 5.5, that's our lower boundary, are considered our lower outliers. Likewise, to find our upper outliers or higher outliers, we're going to add the answer from step 2. So we're going to add this 7.5 to our quartile 3. So quartile 3 is 7. If we add 7.5, that's going to give us 14.5. So anything above 14.5 are going to be considered our outliers, like on our higher end. And so up here in step 3, we didn't have any numbers that were less than negative 5.5. We don't even have any negative numbers. So we don't have any outliers on the lower end of our data. However, we do have 2 outliers on the upper end of our data, 16 and 24. 16 and 24 are both higher than 14.5. So they are both considered outliers. That means if I took this, and these were my average test scores, and then all of a sudden I had these 2 test scores, those test scores would really bring up my average grade. Those scores are going to affect the mean. They don't affect the median as much, but they affect the mean a lot. So to represent this on a box and whisker plot, I'm going to move this stuff out of the way so I can show you down here. To represent this on a box and whisker plot, all you do is you create the box exactly the same. So we have a box, right? And our median, what was our median? Our median was 4.5. So this number is 4.5. And our quartile 1 was 2. And our quartile 3 was 7. The difference in a box and whisker plot when you do have outliers, a way to represent them, is you can maintain the numbers in your without your outliers. So our min was 0, and that's okay. Our outliers were actually way up here at 24 and way down here at 16. So we can put little asterisks right there to show that those are outliers. And our new max on our box and whisker plot just becomes the first number that's not an outlier on that end. So if you look up here in our data set, number 8, the number 8 was the first number, the last number, to not be considered an outlier. So we could put our new max at the number 8. So this tells us a lot. It tells us still what our median of the data was. It tells us still what our quartile 3, quartile 1 are. It tells us our min. And then it tells us our 2 outliers and our max number right before our outliers began. So that is how you would represent it on a box and whisker plot. If you ever see these 2 stars on a box and whisker plot, that just means that those are considered, technically, mathematically, those are considered the outliers. Okay, so for these 2 questions, I want you to do the first one on your own using the notes that you we just went through together. So refer back to what we just did together to try to answer this first question here. Then I want you to show me what you got. Show me your work before you move on to the second part. So I want you to do this part first, come and show me, and then I'll have you move on to the second example. Okay, see you in class.